Class initialization in Python. I found that some classes contain an underscore in an underscore function, and some don't. I'm confused about something described below. What is the difference between these two pieces of code? And I know that the result or any instance created by these two classes and the way of getting their instance variable are pretty much the same. But is there any kind of default or hidden initialization mechanism of Python behind the scene when we don't define the underscore in an underscore function for a class? And why I can't write the first code in this way? That's my questions. Thank you very much. Thank you very much, Auntie Hopala. Your answer gives me further understanding of my questions. Now, I understand that they are different in a way that one is a class variable, and the other is an instance variable. But, as I tried it further, I got yet another confusing problem. Here is what it is. I created two new classes for understanding what you said. As you said in the answer to my first questions, I understand the class underscore variable is a class variable general to the class, and should be passed or changed by reference to the same location in the memory. And the instance underscore variable would be created distinctly for different instances. But as I tried out, what you said is true for the test3's instances, they all share the same memory. If I change it in one instance, its value changes wherever I call it. But that's not true for instances of test4. Shouldn't the int in the test4 class also be changed by reference? I1 equals test3. Why is that? Does that equals create an instance variable named I without changing the original test4.I by default? Yet the append method just handles the class variable? Again, thank you for your exhaustive explanation of the most boring basic concepts to a newbie of Python. I really appreciate that.
In Python, the instance attributes, such as self.I, are stored in the instance dictionary, I._dict_. All the variable declarations in the class body are stored as attributes of the class. Thus, is equivalent to if no _init_ method is defined, the newly created instance usually starts with an empty instance dictionary, meaning that none of the properties are defined. Now, when Python does the get attribute, as in print_instance.I operation, it first looks for the attribute named I that is set on the instance. If that fails, the I attribute is looked up on type I instead, that is, the class attribute I. So you can do things like but what this actually does is, there is no I attribute on the newly created T at all. Thus in T.I plus equals 1 the dot I was looked up in the test class for reading, but the new value was set into the T. If you use _init_, the newly created instance T2 will already have the attribute set. Now in the case of a mutable value such as int, there is not that much difference. But suppose that you used a list versus. Now, if you create two instances of both, C1.the_list and C2.the_list refer to the exactly same list object in memory, whereas I1.the_list and I2.the_list are distinct. Modifying the C1.the_list looks as if the C2.the_list also changes. This is because the attribute itself is not set, it is just read. The C1.the_list.append 42 is identical in behavior to. That is, it only tries read the value of attribute the underscore list on C1, and if not found there, then look it up in the superclass. The append does not change the attribute, it just changes the value that the attribute points to. Now if you were to write an example that superficially looks the same, it would work identical to and do a completely different thing. First of all, the original plus 42 would create a new list object. Then the attribute the underscore list would be created in C1 and set to point to this new list. That is, in case of instance.attribute, if the attribute is read from, it can be looked up in the class or superclass, if not set in the instance, but if it is written to, as in instance.attribute equals something, it will always be set on the instance. As for this, such thing does not work in Python, because there is no self-defined when the class body, that is all lines of code within the class, is executed. Actually, the class is created only after all the code in the class body has been executed. The class body is just like any other piece of code, only the defs and variable assignments will create methods and attributes on the class instead of setting global variables.
I understood my newly added question. Thanks to Andi Hopala. Now, when Python does the get attribute, as in print instance.I operation, it first looks for the attribute named I that is set on the instance. If that fails, the I attribute is looked up on type I instead, that is, the class attribute I. I'm clear about why is. After few tests, the code actually creates a new instance variable for J1 without changing the class variable. That's the difference between equals and methods like append. I'm a newbie of Python coming from C++. So, at the first glance, that's weird to me, since I never thought of creating a new instance variable which is not created in the class just using the equals. It's really a big difference between C++ and Python. Now I got it. Thank you all.
If you want to see more, please consider subscribing.